Hello everyone and welcome to yet another recreation programming session with Mr. Zozin. So as you probably know, maybe you do not, I'm developing a 3D software rendered game. So here it is. This is not OpenGL, by the way. It's rendered completely on GPU, on CPU. Right, pixel by pixel, and it is rather fast, right? So as you can see, it's in hundreds of FPSs, right? So it's not that difficult to do something like that in 2025 because CPUs are actually quite fast. We do not notice that because we kind of focus on GPUs a lot, but that's besides the point. So some time ago, I think a couple of days ago, I decided to go into back-face culling, right? So it's basically an idea is that here you have a lot of like pillars, right? So here are the pillars, and they're basically stacks of cubes. You can like walk around them, and yeah, so that's the cubes. But what's interesting is that when you look at these pillars from this side, other sides of these cubes, you can't see them. But our renderer processes them anyway, and it's wasting CPU cycles on them. And yeah, so it would be kind of nice to somehow like identify that you can't see them, so just don't render them, just don't spend any time on processing them at all. And one of the ideas in here is using back-face culling. So let me demonstrate you like how it works. So essentially, we take our triangle and we decide which side of the triangle is a front face and which side is a back face. And essentially, if you are looking at the front face of the triangle, you display the triangle, but if you're looking at the back face of the triangle, you simply do not display it and you don't spend any time on the triangle. So let me actually maybe prepare this scene a little bit to demonstrate how exactly it works. I already kind of implemented it, actually, believe it or not. I already kind of implemented it. So where's the renderer end. So here is the scene where I render everything. So let me comment out rendering the Utah teapot and rendering the floor and the pillars. So I only want to leave the quad and the triangle. So that's what we're going to be having in the scene as of right now, because I want to simplify this scene just to demonstrate how all of that works. There we go. So here they are. We don't have anything but the quad and the triangle. So let me enable back-face culling. So it should be enabled right now. I just pressed the button. And if I walk around those things, as you can see, they are disappearing. And if I walk like that, they are appearing. So it already works. I already have that implemented. And surprisingly, it is actually very easy to implement. I actually kind of lost in the space. I can't make them appear. Right, so there's no any frame of reference in here. I actually kind of got lost, so yeah, I'm moving around. I lost them. That's totally fine. That's totally fine. It's actually kind of interesting how this entire thing works. Right, so to understand how you even do that on mathematical level, 1000 FPS. Yeah. So this is because we don't have anything else, right? So we have only 3 triangles. So 1 red triangle and 2 green triangles. And rendering something like that on a CPU is actually not that difficult. It's just like 1000 FPS. Like, come on. Right. So you know, modern CPUs are fast. Modern CPUs are fast. So to understand how you even do that, we need to understand what is a winding order in 3D rendering, in 3D software. Winding order is rather interesting. So let me actually maybe open my paint because I want to draw a little bit. So let's imagine that we have a triangle. Right, so this is going to be one vertex, here's another vertex, and here's another vertex. So essentially, winding order is how we number the vertices. There's 2 ways to number the vertices. It's a clockwise order and counterclockwise order, right? So for example, let's actually number them in counterclockwise order. So this is going to be 1, the next one counterclockwise 2, and then 3. So the winding order is like this. So there you go. So let's actually do another order. All right, let's do another order. So this is going to be 1, clockwise order, this is going to be 2, and this is going to be 3. So that's another winding order. So, and essentially you have to pick a convention. Which order do we consider the front face and which one do we consider the back face? Right. So usually, according to, I think, OpenGL standard, the counterclockwise, which is denoted as CCW, if you work with the OpenGL API, you will actually see this abbreviation quite a lot, CCV and CV, and it refers to the winding order. Right. So, and counterclockwise is basically the front face, and clockwise is a back face. Right. And here's an interesting thing. If you render all of your triangles keeping this order in mind, it is actually very easy to detect which face you are looking at, right? Because after all of the translations and all of the projections, you end up with 3 2D points on a screen space. Right, the triangle is in 3D space. You have a certain camera looking at it and so on and so forth. It doesn't matter. You do all of the transformations, you do all of the projections, and you end up with just 3 points, 2D points, mind you, 2D points on a screen. And if on a screen they end up in a counterclockwise order, that's the front face. If they end up in a clockwise order, that's the back face. You discard the entire triangle. That's how it works, believe it or not. It is extremely dumb. Right, so, and whoever came up with that is a freaking genius, right? So you just decide what order it is. You do all of the transformations since you know what's the order, like you see at the order on the screen, right? So the final, before you're about to do the pixel and fragment shading, right? And then you see, okay, it is a clockwise order, you just discard the entire thing. Right, so, and how do you even know in which order they are? Right, how do you even know in which order they are? You can try to maybe come up with an algorithm that just like looks at their position and stuff like that. But the easiest way to go about it is to use cross product. Right, so essentially you just turn the entire triangle into 2 vectors, right? 1, 2 and 1, 3, and you take a cross product of them. And the cross product has a very interesting property. So let's actually take a look at it. So cross product, humble cross product, yeah. So you usually take a cross product of 2D vectors or vectors that are in the same plane. Well, I mean, if you have 2 vectors, they're usually in the same plane. And the property of the cross product is, believe it or not, literally determining what's the order of the vectors, right? So essentially it will tell you, depending on the result of the cross product, whether it's positive or negative, whether the vector go in a clockwise order or clockwise order. Right, so believe it or not, cross product is literally telling you in which order vectors are. Is it clockwise or counterclockwise? And it just depends on whether it's going to be negative or positive. So yeah, essentially you pick an order, then you project your triangle, you turn your triangle into 2 vectors, take a cross product, look whether the vectors are clockwise or counterclockwise, and just discard the whole thing based on that. Simple as that. In fact, this is literally what I'm doing in here. Let me find Back-Face Culling. So here is the Back-Face Culling. It's behind the flag, right? So it's behind the flag. And look at that. I just have 3 points, 3 vertices of the vector already projected on the screen and everything. I take a cross product between 1, 2 vector and 1, 3, right? Just take a cross product. And then using the z of the vector of cross product, because that's basically the result, I just decide whether it's greater or equal to 0 or less. And then I just discard the rest of the code in here, which is kind of, you know, performance, which has a very low, like, slow performance, right? I'm forgetting the words. So that's the entire thing. Like, this is the entire thing that is performing Back-Face Culling. So which is kind of cool. So, and I enable it and it actually kind of works, but the problem is that I introduced Back-Face Culling before I was following any convention on the winding order of my vertices. Right. So for Back-Face Culling, expensive to calculate. Thank you so much. Thank you. Well, English is not my first language, so sometimes I can find it difficult to find the correct words. So yeah, I introduced Back-Face Culling before I you know, decided on any winding order of my vertices. So, and just slapping the back-face culling is not enough for your game to look good. So let's actually go back to enable to our scene, right? So I disabled the whole scene for a particular purpose, actually. So render end, so where it is. So we have all of that stuff, right? So let's actually re-enable the whole thing and let's run it. Okay, so here's the whole scene, and let's enable back-face culling with this scene. Yeah, so but this is because, like, when I defined the procedures that render all of these cubes, I didn't even think about the winding order at all, so they kind of end up fucked. So interestingly enough, Utah teapot actually is fine. You can go inside of the Utah teapot, and here are the back faces, and you can actually clearly see that the back faces are culled perfectly, right? So, and here are the test triangles and stuff like that. Everything is fine. So the only problems that we have are these pillars. And by the way, you can finally see how they're organized, by the way. So they're just a stack of cubes, which by itself is already waste of resources. If I wanted to just make these pillars, I could have made like just a single stretched cube, right? And that would have been even faster, right? So by the way, look at the FPS when I enable back-face culling. It doubles, which kind of makes sense because you don't see half of the faces. So this is an actually working optimization, right? So I was trying to optimize the actual sort of like a fragment shading, which is very difficult to optimize, and any optimizations in that area doesn't really give you that much. The best optimization that you can actually have with the software renderer is to just never go into the fragment shading, right? So try to avoid going into the fragment shader as much as possible. Cull as many triangles as possible as you possibly can, and that's what gives us speed up. And as far as I know, it's also the case in a hardware accelerated rendering too, right? So a lot of optimizations is just like essentially remove as many triangles as possible from like drawing at all. So the best optimization is just does less, yeah. So, and kind of confirms that. It kind of confirms that. So yeah, so look, but right now I think it's kind of good to have you know, pillars as a sequence of cubes because it's basically stress testing, right? So I think it's a pretty good stress testing. So there's another problem. Fixing the winding order of the cubes is not the most difficult thing. I think we have a little bit of another problem. Let me actually disable Utah teapot. Let me disable Utah teapot and I'm going to show you. Okay, so here's the test triangle, right? And currently I'm looking at it when I can't see it. Like, you know where it is, right? So here is the triangle. I can come a little closer. Then I go here and I can't see it. But if I come to it a bit closer, I can see it again. And then I can't see it. So we have a little bit of a code which is responsible for near plane clipping. Right, a near plane clipper actually splits the triangle into several triangles, so it doesn't go behind your eyeballs, right? So because somewhere there you have like a very nasty number instabilities, and it just like drops the FPS like crazy. All right, so we're just trying to avoid that. And essentially, when I like implemented that clipper, I didn't respect a winding order as well. So we'll have to revisit it and actually make it at least respect the winding order, right? That's kind of the two things that I need to make in here. And you can even see that effect on the floor. You see some of the triangles here are literally missing because of that clipper, right? So near plane clipper is kind of don't work correctly with the winding order. So far, it's very easy to introduce back-face culling, but it creates all of these problems that have to be fixed separately. And this is basically what I wanted to stream today, right? So I plan to actually do that off screen, but then I got bored and I thought, like, let's just make it on the stream. Like, why not? Shouldn't be that difficult, honestly. Shouldn't be that difficult. So sounds good. Sounds Gucci, Tamaguchi. So is there also some floor artifact that arouse when you enable? Yeah. So it's basically because of the clipper, because of the near plane clipper. Tamaguchi. Okay, cheers, by the way. The near clipping plane is inverted. Yeah. Okay, so let's actually see how we can even do that. So the procedure responsible for the near plane clipping, not really near plane clipping, for placing the cube. I think it's literally called place cube. Yeah, there you go. So you can provide the position, you can provide the rotation. Rotation is basically 3 floats, and it's basically a rotation for each individual axis. We don't use quaternions or anything like that, so I just like doing a very dumb rotation in here. But it's kind of temporary. So placing the cubes, and basically I took the mesh of the cube from this Stack Overflow answer, and I think it is literally not respecting any winding order at all. Right, so, and it's written by C++ developers, of course they have zero respect for winding order. I'm joking, by the way. I'm joking, by the way. Anyways, so yeah, so what we can do in here, we can try to maybe create our own mesh, which is kind of tedious, right? So it is kind of tedious, or we can maybe find a cube mesh, cube OBJ file somewhere. Can we try to do that, chat? Okay, so cube OBJ file, Babaji file. So we have this thing, simple 3D cube in various formats. Okay, so people even done something like that. Okay, so we have cube OBJ, and this raises the question, does it use the correct winding order? It probably does, right? So it probably does, and if it's created with Blender, though this is a lot of custom comments, so it's probably not created by the Blender, but we can try to create it with the Blender. Can just open it and hit export. Yeah, that actually sounds like a good idea. Do I even have a Blender? I don't even have a Blender, chat. How come? I think I do have a Blender in my other account somewhere here. So yeah, can I just open it like that? I should be able to open it like that. Yeah, there you go. So save preferences. Okay, escape. So how do I export things? So this is export. Wavefront OBJ, and let's maybe go to le programming sorting, and can I sort by modification date? So yeah, it's actually not sorting, just a second, it is probe, if I'm not mistaken. Yeah, here is the 3D software, and let's just have a cube OBJ. So export wavefront OBJ. Okay, so let's actually see. That was the easiest generation of the cube in my entire life. What the fuck? Okay, so it also created like a material stuff, right? And here is the OBJ, and there is, yeah, so here is the material. I'm not really sure if I care about the material. MTL cube, MTL. Yeah, so I remember that I had OBJ parser somewhere in Olive C. Do you guys remember? Right, so we do have that in Olive C. Let me... Oh, that's a lot of changes for the WASM stuff. So, yes. So here's the latest commit and everything. Yeah, so for those who doesn't know, Olive C is just like the graphics library that I implemented some time ago. So maybe I'm gonna do it in here. So OBJ2C, yeah, so it does have a utility that is literally called OBJ2C. So OBJ, yeah, OBJ2C. So it takes OBJ and it just converts it to C code that you can include. In fact, in the game, we kind of use the result of that utility. So instead of integrating that utility into the game, what I did, I just copy-pasted the result of it, which is just a Utah teapot. If I'm going to be integrating OBJ2C to my game, I might as well also generate Utah teapot from that OBJ file. So that's actually convenient. Olivettes. Right, that's right. So that's how it's pronounced. It's basically continuation of that idea is that the letter C, as we said in the pre-stream, is actually read as C in the Slavic languages that use Latin alphabet. So that's kind of the same idea in here. Anyways. So I think maybe what I have to do, I have to copy paste OBJ to C. Let's actually go and do that. So where's the tools? Here are the tools, and let's put them into src_build. So I recently kind of, merged together all of the different PNG to C, Wave to C, and TTF to C into a single utility called assets to C, and it just like puts everything into a single C file that I can include. I think it's a little bit more convenient. And I end up with something like assets.h, which contains the fonts, right? So different fonts, and also it contains the images, right? So I think it's more convenient to just like have a single thing that packs the assets, right? And generates a single C code. But honestly, in the future, I don't even want to generate C code. I kind of want to pack it into binary blob and then just like store offsets within the binary blob to different assets and stuff like that. So I'm pretty sure a lot of engines actually do that. So I'm kind of slowly moving towards that, and maybe in the future that asset packer is not going to generate any C code, it's going to be just basically generated in the blob. Zozin WAD. So that's what it is, right? So I kind of vaguely remember that it has something to do with Doom. And it's just basically the assets, right? So seems more efficient, yeah. So, and honestly, this kind of approach of generating C code, it's also slowing down compilation quite dramatically, right? Because this is at 3 megabytes of C code, right? And it's not even that many assets yet. It's not that many assets yet. And imagine that the C compiler, the poor C compiler implemented in C++, has to go through all of that, right? So, and it's just like very inefficient and slows down the compilation. You don't want to do that. Thank you so much for your subs. Thank you, thank you, thank you. So, what happened to Vim? To be fair, I just like switch between Vim and Emacs depending on what I need to do, right? So I personally don't really have that much preference between these two text editors. I can use whatever. I can actually use whatever. But anyway, so, but for now, like I'm not really sure how I can integrate OBJ to C into the assets to C. So because of that, I think I'm gonna just literally compile it as is, as a separate thing. So in a build script, we have rebuild tools. Let me take a look at it. So the tools that we are rebuilding is assets C. So that's the input. Yeah, so there's only a single tool in here. All right, so can I build a different tool? So as you can see in here, I'm trying not to rebuild that tool too much, right? So, and yeah, that's kind of interesting. So I'm checking whether I want to rebuild it, whether it was forced to rebuild, and then I'm doing all of this entire thing, which makes me think, can I just factor out all of this code into separate things, something like rebuild single tool, right? Rebuild single tool. And obviously it's going to contain the inputs and outputs, right? So that's one thing I want to do in here. So it's going to be inputs, and it's probably something like that. And it has to be something like inputs count, and it has to have the output, right? So something like that. And let me just literally grab the whole thing and just put it in here. So that's the thing we have in here. Rebuild a single tool. Okay, so let's copy paste this entire stuff and put it in here. So this is the inputs. Inputs count is basically the size of this array. It's going to be array length inputs, and this is going to be the outputs. Obviously it can fail, right? So we have to take that into account. So that way it should be easier for me to actually create more tools in here, because I can put that into a separate scope, and for example say, okay, so now we're building not assets to C but OBJ to C. And this one is going to be OBJ to C. And interestingly, look at that. They are kind of independent, right? So both of these things are kind of independent. So it kind of makes sense to maybe build them in parallel, right? So let's actually quickly do that. So there's only one CMD running here. So let's do async. So this is going to be async, and let's put that into prox. As far as I know, prox is a global thing. So it's basically mechanism of knob, right? So for those who doesn't know, I'm using like knob for building my entire game, obviously, right? So you can find it in here. But I'm pretty sure like everyone who watches me like kind of knows what is knob. So we don't have to explain that. But maybe there are some new people in here. Just in case there are some new people, I'm going to explain what it is. It's my building tool. So and after that, we're going to do prox flush. and just wait on all of the processes in here, like so. There we go. Okay, so let me see if this entire thing even compiles. So no, it doesn't. Surprisingly. So where did I do a fucky a wacky? Yeah, I can see where I did a fucky wacky. So essentially I didn't return true, and this is because the auto recompilation script didn't properly check for anything. So I have to do w-all, w-extra, o, nob, nob.c, and only then it will show me all the warnings. So one of the downside of nob is that yeah, so it uses a very fixed command line to rebuild itself. But it's actually customizable. So look at that. You can do nob. It probably makes sense to touch the knob. We're touching the knob and we're running it. And as you can see, it used this specific command line to rebuild itself. It doesn't use any warnings or anything like that. Maybe it should, by the way. Right. But this is actually easily customizable, right? If you don't like how knob rebuilds itself, you can always redefine a special macro that is used to rebuild, right? So something like go rebuild, or maybe just like, I don't remember, I think it was knob rebuild yourself. That's how this macro is called, right? So essentially, if you never define that macro, the library defines it for you, right? So, and we can just grab one of the definitions in here that kind of suits us, and we can define it some way here. So this is going to be cc, right? So here we can add w-all, and then we can have w-extra, and all the stuff that you want to have in here, right? So maybe I want to even put all of them in separate lines, right? So to make them stand out, something like that. Also, it probably makes sense to actually wrap them in parentheses, but it doesn't really matter. Okay, so now if I try to recompile the whole thing, right, so I probably have to recompile it one more time, right? So for this thing to take effect, and as you can see, now it is using our command line for rebuilding itself, right? So you can actually customize that aspect of knob. So, but it's only going to work on Linux, right? So because on Windows you probably don't have CC, unless you're using WSL. Does anybody know? Like I haven't used Windows for a very long time. Can you just have CC in WSL shell? Right, is that something? No idea, I have no idea either, I'm sorry. Right, so but one of the things I like to do is just like if not defined MS with C or Win32, so you can actually have that. Right, I don't know. Does anybody even do like a system C, C++ development on Windows outside of WSL except Jonathan Blow? No offense to Jonathan Blow, by the way. I think it's a best way to develop things on Windows, by the way. Me. Oh, okay, so there's quite a few people. I suppose it's a game development thing, right? So people do that. Casey also do that. All right, so, okay. And I'm just like asking not to make fun of anybody. I genuinely don't know because I'm not a Windows person, right? So, so I don't know how it is on Windows. So CC works there. Okay, that makes sense. Anyway, okay, that's very interesting. It's kind of interesting that I like daily driving Linux for a very long time already, and it's totally fine. And I wonder why. Maybe because I do not depend on any special software, and I also don't really play video games. Maybe that's the reason. So, but I don't know. I kind of didn't need Windows that much even when I was working, was even freelancing, right? So, but I like strategically picked gigs where I didn't need Windows, right? So that kind of made sense. I play video games on Linux. Same, actually, believe it or not. I play video games on Linux too. Specifically, I play a lot of SNES game on an emulator, so that's kind of cheating, but I mean, that's game nonetheless. That's gaming. It's a retro gaming, but it's a gaming nonetheless. Those are good. Yeah, those are good. SNES games are pretty good. And I'm telling you that as a person who never had SNES in his childhood. Honestly, like I never had it. And I just play the games on SNES and they're amazing. If I had SNES when I was a child, I would just, I don't know, I would fucking blow up. It is so much fucking better compared to Sega Genesis. But I mean, because it's the console is more powerful, obviously. But yeah. SNES has go-to game. Yeah, that's true. That's true. That's true. The only console I had when I was a child is this Sega Genesis. So that's good, right? So it has quite a few good games like Comic Zone or all of the Sonic series, but it's not even comparable to SNES. So yeah. Anyways, so let me see. Okay, so it complains about this kind of stuff, right? So this is a length. Okay, and yeah, so we need to replace that with the inputs count. So what other warnings do we have? What other warnings? They're kind of all related to the length of the array, which is actually understandable. Right, so and a control flow reaches this stuff, so we have to do true in here. And there we go, so that seems to be working. Right, so does it always rebuild the tools? No, yeah, so we actually told it not to rebuild the tools. That's kind of cool. That's kind of cool. I don't really like the fact that it kind of hard codes the what is it called? I forgot the library. Maybe we could have moved that outside and mandate to sort of like run command yourself, similar to how you, yeah, that's actually kind of a cool idea. So essentially, if we don't actually run this command, there's nothing to fail in here, so this boolean can be freed up for something else. And I'm thinking, what can it be freed up for? It could be probably freed up for just telling you whether you want to rebuild a thing or not. That's kind of an interesting idea, honestly. So if you need to rebuild, you can say true. Okay, so you're saying true. And if you don't want to rebuild, you say false, right? So the only thing this entire function does, it just tells you whether you need to rebuild or not, and it also appends some stuff to the CMD. So that way, you can say if rebuild, you also want to append CMD math, like basically this thing, 15, just put it in here, and also do CMD run, CMD async procs, and this entire thing may fail. We're going to return false in that specific case. That's an interesting approach, actually. So this thing doesn't really call the command, it's only for constructing the command, but on top of that, if you don't want to, if it doesn't construct anything, it just returns false to you without even appending anything, right? So because, yeah, it will never even go into this piece of code if it doesn't need a rebuild. Kind of like this approach. So I wonder if it will evolve into something actually interesting. Something like that, and obviously this one has to be just the right thing. Can your CMake do that? I don't fucking think so. So if you want to do just an arbitrary thing in CMake, you have to sell your soul to the devil, like literally. it's an absolute suffering, honestly. So I actually put -b to actually force the rebuild. I just want to see how both of the tools are rebuilt. Okay, so that seems to be all right. So we have obg to c, babaG to c. So, and what it does, it accepts input obg, right? So that's pretty cool. We can supply maybe the cube obg. All right. So, and we also have to supply the output. So let's actually say this is going to be cube c. We can put that. Yeah, let's actually put that in the current folder. Okay, so there's a bunch of warnings, which I remember, by the way. So it doesn't implement the entirety of the obg format, but it seems to be actually working. Damn, motherfucker works. Wait. This tool just works. What the fuck? Did I implement that? Damn, absolute truth. Maybe you should release that as a separate tool, because it's just like I just took it, it's self-contained, I compiled it, and it's, yeah, so it takes OBG files from the Blender and generates C code out of them. So it just works, yeah. Might as well actually, wait a second. So let's actually put all of that stuff into the assets. So can I just have maybe OBG, right? So this is OBG, and we can put all of that stuff in here. So all of these, yeah, so I was thinking that this is a plural, and so because of that I need to make it also plural, but audio is not plural, but audio also is not countable, so that's totally fine. Okay, so that's going to be convention, so all the folders has to be plural. So and in here, we are rebuilding assets, right? So we are rebuilding assets. As we rebuild the assets, so here I just call assets to C. And as far as I know, the paths to the assets here are literally hard-coded. Okay. So in here, what I want to do, I want to do append cmd build folder, and it's going to be obj to C. So cmd append cmd, right? So, and what do we have in here? Do I have assets folder? I remember that I had folders somewhere. I think it's called, yeah, so it's an assets folder. There we go. That's an assets folder. Within the assets folder, we have OBGs, babags, and the cube OBG. Let's go. So that's what we put in here. And we also have to specify the output. I'm going to put the output literally into the build folder, cube.c, and it probably has to be something like O. Right, and let's just run this command. And since these commands are kind of independent, it doesn't hurt to make both of them asynchronous. Let's just make both of them asynchronous. Let's go. So, and then if procs flush, flush I said, I'm going to procs, not flush, return false. So that should be fine. Okay, let's try to rebuild the whole thing. Boom. So is it done? Yeah, it is doing. It's actually building the thing, which is kind of cool. And then in here, in the build, we have cube.c. So, but it generates kind of a names that are polluting the namespace, if you know what I mean. They kind of are polluting the namespace. So we need to have a way to specify a custom name. So obj to c. So does it have, it doesn't even have a name specifier. So this is probably something that we'll have to introduce into obj2c. So how does it even parse the command line stuff? Oh, it's one of those programs. Okay. It has a lot of different, okay, so what is this flag? It's delete components. So I remember, like, I introduced the flag that is just deleting certain components, and this you provide the index to delete a component. Fascinating, fascinating, fascinating. All right, so maybe we should introduce flag.h. Consider using flag.h, Kappa. Thank you, Chad. I haven't thought about it. So, and we even have like a flag lists, but this is kind of an interesting flag list. It's a flag list of integers, but in our case, they are strings. Flag.h only supports strings, but I think we can do something about that. So it's a str to f, and this is floats. Okay, so let's actually try to include maybe, to be fair, I kind of don't want to spend time on that. So let's just extend whatever we have in here and just be done with it. All right, so if else, I will integrate flag.h after the stream, right? How about that? Line 251. Oh. Well, shut up, Zuzin. Shut up. Okay. Freaking. Somehow I'm backseated not only by the chat, but even by my past self. Okay. That's kind of funny, actually. All right, but I'm gonna do that later. I'm gonna do that later. So God damn it. Anyway, so we probably have to have something like a name, right? Namespace. Fuck. Well, I mean, it's a C++, but I mean, I can always put underscore in here. Maybe a name prefix. Let's call it name prefix. That's a little bit better. Get backseated, nerd. Yeah. so is the strcmp, and this is going to be, can I split the screen in two so I can see some examples? So we do flag, and I suppose this is going to be n, right? So this is going to be n, and in here we can say something like no value is provided for the flag. That's understandable. Then I basically grab the flag, and I can just use that, right? So I can just say that this is the name prefix. Name prefix. By default, we can set the name prefix to something. I don't freaking know. We can say it's obj2c underscore, right? obj2c. And how are we going to be approaching all of that stuff? So this thing generates different names, such as vertices, text coordinates, normals. It even generates normals, which we can use, by the way, probably. Faces, and that's about it. But I don't remember. I think each of these faces is just like one of the enumerations. So this is vertices. Some of them are texture coordinates or normals or something like that. I don't really remember like all of them. But in any case, so let's find this specific name. So here are the vertices. Here they are. Found them. Generate code. Okay, so that's what it is. And I suppose here we literally have to put something like this. Because of that, obj2c, let's remove that underscore because that underscore is provided by this entire thing. And this is going to be name prefix, which means that we have to supply that name prefix in here. So const char name prefix. Let's go. And let's just go through all of these things, right? So this is going to be that name prefix. Name prefix. This one is going to be as another name prefix. Cool. Texture coordinates. Guess what? Name prefix. Name prefix. But what about text coordinates without the count? Name prefix as well. Name prefix as well. Right. So how many of these things, by the way, we have? Name prefix. What about include guard name? That's a good point. We can put that in here as well. So it's just something like this, and it's gonna look goofy because it's not capitalized. It's not capitalized, but that raises the question, do I have something in the nub to capitalize? We don't. Do I have something like strdupe? We do. So I can actually do tmp strdupe, right? So I can literally dupe name prefix. And I can say, this is the upper name prefix, like that. And then I can say, I don't know. So the easiest thing here would be to have some sort of an iterator, which is pointing at upper name prefix, and just simply iterating the whole thing. So essentially, while as, what we do is just we take that as to upper and we assign it back. So that kind of makes sense, and then we increment it by 1. So something like that. So this is just basically to upper for the entire string. Would be kind of cool to maybe even factor it out to something else, right? So tmp to upper, or maybe something like a sister to upper, or to upper sister. So I take this entire thing. So this is going to be just, you know, regular as, right? So, and we have to, so we have to dupe this as, so we can call it a result, right? So this is a result. Then we take the result, and we're, yeah. So I just have to call this differently, right? So, or maybe I can call this thing differently. I can call it an iterator, right? So because the whole point of this entire thing is iterating. So what it does, it just like brings the whole string to uppercase, also allocating a temporary allocator. So that way I can say, okay, TMP to upper sister. Yeah. So, and we have upper namespace prefix, which we can use in here. Upper namespace. So there should be somewhere and if in here, and we can actually do a similar thing here as well. Okay, upper name prefix, like that. So this is just a regular one, and we also have like upper one. Okay. Okay, so here is the rest of the stuff. This is the normal, so might as well do something like that, and this is going to be the name prefix. Okay. Do we have anything else? This is the faces. Okay, I'm going to be that, and we can put name prefix in here. All right, let's go to the compilation errors, by the way. I think the time has come to go to the compilation errors. Nope. Okay, it doesn't compile, obviously, because I forgot. Aha, I did that in an incorrect order. Happens to the best of us. So where did I put name prefix? Yeah, so name prefix goes here. There you go. Cool. So no value is provided for flag cube. Ha, that is fascinating. That is absolutely fascinating. I fucked up something, chat. I fucked up. Where is n? Here it is. Aha, I see you. I forgot 0, so I remember that. Okay, so what else do we have in here? So as of right now, cube.c has a prefix obj to c. As you can see, this one is properly capitalized and this one is not, right? So that's exactly what I was trying to achieve, and all of that gives you a namespace. Which means now I can do nob.c, and what I can do, I can just put an n in here and say that the namespace, the name prefix is going to be cube. So let's go into here and let's revert the whole thing, and there we go. Here is the cube. All of that is prefixed perfectly. So to count define prefixes. Did I? Oh, that's kind of... For some of them I actually did, but not for these ones. Okay, all right, let's go ahead and do that. So generate the code. So this is a vertices count, this is that, normal counts, okay. So this is a name prefix. So name prefix, which one? And that's another one. There we go. Name prefix. Cool. Cool. I guess that's it. Well, so since I'm actually generating stuff for the cube, I might as well try to get rid of this stuff that I had coded and generate the Utah teapot myself. I think I should try to do that, chat. So where's the Utah Tiputa object file? I'm pretty sure it is located in Olivets. And we do have assets in here. And where is the Utah Tiputa? So let's put Utah Tiputa into the OBGs. Right, so here it is. Here is the Utah Tiputa. It's actually a pretty big file. Look at that. It's almost 10,000 lines of text, right? So, and it's taken from here. It's from Graphics Stanford course. Okay, that's pretty cool. So now we can try to generate some assets. So let's do the following thing. So assets OBGs. So Utah OBG, like so. The output is going to be Utah Tiputa, and let's call this Utah Tiputa 2. All right. So, and all of that is actually in parallel. All of these three commands are in parallel, which is nice, I think. Because they're independent, there's no reason for them to be executed like in sequence. Doesn't make much sense. Okay, so, and that seemed to be working, right? So that seems to be working. And here is the generated Utah Teapot. Yep. So it just has everything. I wonder if I try to build the whole application, which I actually kind of did, and it worked, right? So it actually worked. I'm surprised why, because I didn't remove. Okay, so let me try to remove whatever I have hard coded in here. So that means it's going to fail, right? It didn't fail. How on earth it didn't fail? So I remember Utah Oh shit. The way I include that putah is like this. So I removed it from this folder, but now it is automatically generated in a build folder with literally the same name, and build folder is in the search path. It just picked up automatically first try. What the fuck? So I removed hard-coded putah, replaced it with auto-generated one, but because of the coincidence, it actually picked up normally. So damn, that's actually fucking poggers. What the fuck? So that means auto-generate putah at compile time like in Olive C. Because that's exactly what's going on here. So, and it also means, by the way, I can actually include cube. So now I can include cube, which I took from the Blender. And that should work. So that compiles at least. I wonder how we can try to approach that. So here we have place putah. Yeah, very useful for stress testing the render. So, and we can, funnily enough, so we already have a place cube. I'm going to copy paste the whole thing in here, and I'm gonna just call it place Blender cube, right? Because I already have a place cube that I stole from the Stack Overflow, right? So this is a Blender cube now. So, and in here, I'm gonna just query replace putah, right? And just cube, right? So this is a cube now, because it has the same interface, the same name, it just has a different prefix. So that's what it is. Right, and this is an angle, but I feel like this angle has to be called like XZ angle, right? So because it uses Y as an axis, right? So it's in the XZ plane. So because of that, I want to query replace angle XZ. Yeah, there we go. Wait, this triangle XZ. All right. So, and the same thing is going to be for the putah. All right, so let's go to do it like that. Boom, but not for the triangle. All right, so can I build this entire thing? Seems to be building. All right, so if I try to run the whole thing, should run it. Okay, so that's pretty cool. Now, let me go into where we place putah. And let me put something like place cube, Blender cube. And we're going to use the same angle as putah, right? So because it's kind of convenient. So it's basically a global variable that is constantly rotating. It's a global variable that is constantly rotating, and I'm just using it for the right. So let's actually see how it's going to look like. Fucking Blender devs. But okay, wait a second. No, it's fine. Back-Face Culling is not enabled even, and we already lost half of them. Yeah. What the fuck has happened? But if I enable, by the way, if I enable this thing, it's kind of called properly. It's kind of called properly. So this is not a bug of Back-Face Culling. It's a bug of our exporter or something like that. I don't even know what the fuck is going on. So that's kind of sus. That's kind of sus. So we do a little bit of a like a reversed order because the model has, you know, clockwise winding order. So to make the Back-Face Culling work correctly, we need to push them in a counterclockwise order. So there's something weird in here going on. So I'm not quite sure what exactly. So what if I change the order now? It is reusing some of the vertices. As far as I know, I do take that into account. As far as I know, it is in fact taken into account because we use faces, right? So we look up faces and then we look up these faces in vertices and we're pushing those vertices. So that should be fine. So my Blender has, wait, are you telling me, okay, so that's an interesting thought. intrusive thought that you just gave me. Is it not triangulated? Motherfucker, not triangulated! So OBJ doesn't support non-triangulated meshes, yeah. There's 4 of them. How do I distinguish them even? How do I distinguish them even? Oh, that actually makes a lot of sense. That actually makes a lot of sense. We can try to make Blender triangulated, or we can just try to add a support for that. So we can essentially just take these 4 vertices and just generate more triangles. So I don't know. Which one is going to be easier? That's a real question. Which one is going to be easier? Okay, so I'm going to try to look into the OBJ2C and just maybe I can quickly hack something. Right, so maybe I can quickly hack something. Blender should be fine. Let me try. Chat. What the fuck? All right. So okay, so this is where we do that, right? So this is our OBJ parser, Babaji parser. So I can't even see where am I? Where the fuck I am? Why are you still Emacs? You're dumb. So this is literally in main. Okay. So what is this to do? This code assumes that we already parsed all of the vertices. Since we don't have any OBJ files in the assets that have faces before vertices, it does not really matter that much. If we ever have any of such OBJ files, it's easy to restructure this loop to support any order of the vertices. That makes sense. And as you can see in here, we have something. So, by the way, in terms of faces, if you have more than 3 vertices, what does it mean? Does it mean you have a polygon? So the OBJ2C is not some utils modified from Blender, but pure. Yeah. So I implemented it from scratch, and I implemented it for a very narrow use case. It's so narrow that if I encounter something that I don't know in OBJ, I just throw a warning. So that's how I do that, right? So I mean, but it works. I don't need the entirety of the OBJ format implementation. I only need like a small subset of it, and for the small subset, it's actually very easy to implement. Right. Okay, so what we can do in here, chat? What we can do? So parse face triple. We can do one interesting thing, is that if after the parsing the line is not empty, try to parse the 4th one. So I wonder, like, do we do any stripping in here? Yeah, so we do the trimmage. We do a little bit of a trimmage. Okay, so here's the thing. Here's the idea. I trim the line. So the line has been trimmed. And essentially, if line count is greater than 0, I'm going to do OBJ2C does not support non-triangulated meshes. It's very easy to detect that. So now if I try to rebuild the whole thing, we detected that. So yeah, that was easy. That was actually easy. And what we can do is basically, so here's the vertices items. So V3. So this is the line left. As far as I know, it's a low face and high face. It's a low face value and high face value, and we do that for statistic generation or something. I don't remember what we do that exactly for, but whatever. We can maybe do the following thing. I'm going to introduce V4, VT4, VN4. So, and okay, we append. So essentially we register in which face a certain vertex is used. That's essentially what we're doing. So it's a face index. Okay, so that makes sense. And in here, we just like 3, 4, boom. Okay, this is a 3, 4. Which is rather interesting. So it also automatically updates the faces, but this is not correct, by the way. Right, so I'm going to assume that this thing is using clockwise order, right? For the front face and the back face and whatnot, because this is the same thing the Utah teapot is using. So we're pushing them in a clockwise order, and then we reverting them in a counterclockwise when we're rendering. So that's totally fine. So that means as soon as I encounter the fourth one, I have to just do something about it. So here is the face. I just push that face right away, which updates the face index. Where do we have the face index? Okay, so we need to increment the face index now. There you go. So this is a new face index. If I take a look at the quad, so we can say something like this is 1, and it's clockwise. So that means it's going to be 2. Let's put it like this, 3, and this one is 4. So because of that, I included this triangle already, and it is in clockwise order. So that means now I need to append more different things, more different interesting things. Specifically, I need to make a face out of, so this one is included, 1, 2, 3 is included, the next one 1, 3, 4. All right, so 1, 3, 4, 1, 3, 4, 1, 3, 4. All right, so that is indeed included. Cool, but we also need to register the new face in here for all of the 3 of those things. So because of that, let me copy paste this thing right before we're creating the face. We don't need to parse anything because all of that is already pre-parsed, except maybe this one. So this is what we do, this is what we parse. 1, 3, 4, and that's another face. Right, so we encounter this like quad, and we just triangulate it ourselves, right? Because triangulate the quad is not that difficult. So that was my idea. That's why I wanted to hack it together super quickly. We can now repeat this trick one more time. We can repeat it one more time. And if line count is still greater than 0, right, so we can say obj2c does not support faces with more than 4 vertices. Right, so here is the support for 3 vertices, and this is the 4th one. Support 5 again, yeah. So that's kind of the idea in here. And that's how I approach things, right? So I don't implement the entirety of the thing, I just implement the narrow subset of things I need. Okay, let's give it a try. I'm really curious what's gonna happen. Okay. Cool. That was actually really cool. I didn't expect that it's gonna work first, right? So that's a cube from the blender. Let me actually remove the test triangles, right? So they are not interfering with anything. Absolute badgering. So let's remove that. Let's remove the shades. Okay. That's the cube. I'm inside of the cube, chat. You can't see me. I'm outside of the cube. All right. I'm about to enable Back-Face Culling. Oh, it's the other way around. I can see the insides of the cube. Fascinating. So that means Blender is using also counterclockwise order. So it is only Utah freaking putah. El putah is using clockwise order for the freaking front faces. You flip, I know, I flipped them specifically for Utah. So, and it's Utah, putah. Because it's all, yeah, it's probably why. So as far as I know, I googled around, and from what I understood, the industry standard for winding order right now is a counterclockwise, right? So everybody's using counterclockwise. I suppose OpenGL using counterclockwise, Blender, and that's the old one. It's probably before the convention was established. Utah is wrong now too. Well, we can enable Utah. Let me show you Utah. Utah, putah. So Utah is fine. I do remember that quite vividly, that Utah is fine. Yeah, it is fine. It is fine. I can go inside of it, but I mean, yeah, just a second. Utah is fine. Look at that. This is because I'm reverting things specifically for Utah. It's Utah who's wrong. KC64, thank you so much for the subs with the message. 16 months of epic recreation programming session. Yes, yes, yes. And if I go inside of the Utah putah, everything is culled perfectly. Yes. Fuck. Thank you so much. I get it. I get what you took. Fuck. Okay. Forget everything I said before. All right. It works. Absolute badgering. Absolute badgering. This is the weird behavior is because of the near plane clipping, right? It's a near plane clipping situation. It's just like, yeah, it's kind of weird. But apart from that, yeah, so Back-Face Culling is enabled, and it's working fine with this specific cube, right? So we can try now replacing this entire stuff, right? So instead of using place cube, let's actually place the Blender cube. Let's try to place the Blender cube. So place cube. Okay, so place a column. All right. So place Blender cube. Place Blender cube. The annoying thing about place. Okay, so it doesn't even have a position. Fuck. All right. So let's accept position. So I suppose it's going to be 3F position. Cool. What else does it accept? So where is the place cube? Position, rotation, and size, and also color. We don't really need rotation right now. Let's accept. Well, I mean, we do use rotation at least right now, so maybe that's fine. Okay. So place Blender cube. So because of that, we can try to remove the angle XZ. So we have rotation, size, color, and so on and so forth. That's very cool game. Okay, so let me find place cube, and I'm gonna just say, okay, Blender cube. How about that? It's probably not gonna be positioned properly, right? So it's gonna be probably offset, because if I remember correctly, that Stack Overflow mesh that I stole, it actually positions it. No, it's using 0.5, right? So in our assets obj cube obj. Okay, it is using -1 instead of 0.5, so that just means it's going to be a little bit bigger. But it's all centered, right? So it doesn't use the left upper corner as the position, right? There's a lot of additional information here, right? So this is the texture coordinates. We can actually slap a texture on this cube if we want to, using these texture coordinates. That's convenient. Damn. You discovered an effect to make the cube look hollow, Tsoding. Just invert the list, lol. Okay, so yeah, indeed, discovering old techniques one stream at a time. So yeah, honestly, I'm having a blast implementing this game. I'm having a blast. Look, it's already, the game itself is 1,000 lines of code. Even though the game, like content of the game, like I don't have much content, but the renderer and the whole engine is kind of like, yeah, it's kind of fun. It's kind of fun. I want to just make the performance reasonable on my shady laptop with Intel Celeron. And as soon as the performance is reasonable there, I'm going to start making content and pushing the performance like to its limits, right? So the idea is that I'm going to just you know, slap in the content and see at which moment the engine will start choking. And when it starts choking, only then I'm going to try to optimize things. And if I can't optimize any further, I'll have to make creative sort of compromises, right? So does the Celeron support any kind of SSC? Probably, maybe SSC 2. Do you want to have audio? Yes, I want. It's just like I didn't come around to fix the audio. We already have a provisioning for the audio. Right, so because in the interface of the game, we have an audio buffer, but it's just like I didn't spend any time to make it work properly. Was it on OpenGL? No, it's software rendered. So literally pixel by pixel. So we have root C. So there's a thing called display. It's literally an array. So we have a structure called caller. Where is it? Okay. I can't find it, chat. Ah, this is because it's in the game interface. All right. Caller. There we go. So it's a very simple structure. It's 4 bytes. It's 4 bytes. And then within the game, we have an array literally called display, which is an array of these 4 bytes, and it's of size display width by display height. And we're literally placing pixels in that array at runtime on CPU. So, and so we can run the game. Just a second. Game SDL2. Yeah, there we go. So it works, right? So this is the performance you can achieve on a modern CPU with the software rendering. It doesn't have any lighting. We have a little bit of a fog. Doom style. Yeah, that's basically Doom style. It's basically Doom style. Boom. I really like this effect when you pause the game. It actually changes the distance of the fog towards your face, and it just blends into the menu. And it literally changes the distance of the fog. You can observe that in here. So if you go too far away, you can see how the fog is kind of going through the wall, right? So somewhere here, if you actually go to pause, you can literally see how the fog goes towards you through the wall. You can literally see that. So it's kind of cool. I really like this effect. I want to actually leave it in here. So it's also visible when you're somewhere here. Yeah, you can literally see that. That's very cool. So, and again, no OpenGL. It's just software rendered. And that's kind of the whole point. It's sort of like a creative challenge, right? So I'm not doing that to achieve like cool graphics. Obviously, it's kind of difficult to achieve anything cool with that. It's a creative limitations, right? So specifically limiting myself just to see what kind of stuff I can do. So anyways, I guess I have too much time on my hands, right? What I was doing, yeah, so I wanted to replace the stuff, right? So did it work? I think something got fucked up because with the peeler, so this thing works. This thing works. And then, so column. So place a column. And when we place in a column, so here's the place column. Where do we use that? We use that in here. Okay, that's very cool. But on top of that, this is a little bit weird. I didn't recompile the game. Okay, so explains everything. So I haven't finished compiling the game. So let's just finish the compilation, right? So this is a bunch of warnings. Maybe I should have a way to disable them. So angle X, Z. So this one is easy. So I can just do rotation Y. In fact, I can actually replace this with rotation. Yeah, that's right. Okay, and now what I have to do in here is to add the position. But I don't remember, do I have to subtract or add? I feel like I have to subtract. Oh, fuck. What the fuck am I doing here? Wait a second. I'm adding 0.5. I'm uncentering this thing. Then I'm rotating. Then I'm multiplying by the size, and then I'm adding the position. I see. I see. Which makes me think, can I just do that somehow? So this is just a face. Can I do that for A, B, C, and then I create a triangle out of that? So I'm iterating each individual face. And also I'm iterating faces in here. Chat, I'm having a brain fart right now for some reason. I'm having a brain fart. I feel like, yeah, what I have to do is probably, yeah, okay. Cube vertices. So this is a cube vertex, and I'm turning that. Yeah, so the main problem is that it just generates you an array. It just generates you an array and not the vector. So that's why I can't easily do that. So I think yeah, okay, that's fine, chat. I think I'm getting a hang of it. What I have to do is V1 like this, and then I can do all of the tricks I did in the place cube. I think my brain just got unfarted. I think it, yeah, so it got unstuck. So in here, what I have to do this series of these things, but not with A, but with V1 Zulu. Okay, so A to, well, I mean, it's too much. Can I? All right, so I probably have to do some shit like this. V1 Zulu, and then V1 Zulu. And because this is not a half, this is actually one. Right, so if you take a look at the place cube, the faces, the vertices are half, but if you take a look at the assets in OBGs, they are 1. So the cube is actually twice as big from Blender. So because of that, what we have to do in here is actually replace these 0.5s with just 1. In my library for linear algebra that I use for these vectors and stuff like that, I have a special constructor. So you can just put f in here and remove the rest of the arguments. So it just basically takes the scalar and copies it for all of the components, right? So I could have done it like that. I don't really know why I didn't do that in that place of the code, but it's the same thing in here. So yeah. And essentially now I don't need that code anymore. So that's the vertex 1, essentially. That's the vertex 1. So the other vertex is this one. So, and I can just basically repeat the whole thing in here. So this one is going to be V3, V2, put it like that, boom. And I can move this entire thing in here, put it like that, boom. So this is hard-coded position because we didn't accept position of this thing before. So I suppose we can just remove this entire stuff. And in here, by the way, I can finally just copy-paste the whole thing like that. And I can query replace V1 Zulu, put it like this, then 2, then just something like that. And V2 is going to be V3. V2, V3, boom. Yes, I think I nailed it, chat. I think that's what I wanted to do in here. Roughly. So I can now specify the position, rotation, which I probably don't use, the size, and so on and so forth. So because of that, the cubes are going to be kind of bigger than anticipated, honestly. I think they're going to be bigger than anticipated. All right, so let's freaking go and see how miserably it all gonna fail. It didn't even fucking compile, mates, and it's a little bit annoying that I have these warnings in here, but I'll have to do something about them. Okay, so yeah, that's understandable. That's understandable. So now we have a reacher interface for this entire function. So in terms of the color, we're probably gonna use the color blue, right? So in terms of the size, let's keep the size 1, right? So that's going to be the size. In terms of rotation, this is going to be 0, this is going to be Utah teapot, and this is 0. And the position, I don't freaking know. We can just set it as 0, 0, 0. So just 0 like that. So that's the position essentially. Thank you so much for all of the subs. Thank you. Really appreciate it. Okay, so do I have run? I don't have run in here. So does it compile? Doesn't compile because if I go to semicolon chat, Chat, it happened. It actually happened. Spent 3 hours debugging, and I also forgot to specify the color, right? So I passed the color in here, but I never actually used it in the code. So because I had coded the color. Okay, so I have to do something like color. Have the scale for the cube? Probably, but let's actually see how miserably it fails, and then maybe use half the size. All right. Are we Gucci? Are we Tamaguchi? Let's fuck it. Ooh, yes. Half the size indeed. I'm so sorry. Orbiting cube, yeah, exactly. Something got fucked up. All right. It's kind of close to what I want, but at the same time, it's also so sluggish. Holy shit. Okay. It's also so sluggish. I wonder why though. I wonder freaking why. Something weird going on here. Yeah. What if we... maybe because they are bigger or something. So what's the easiest thing to do in here? Can we just like replace all of these 0 1s with halves? Is that feasible even? Is that even feasible? We can try to do that. So this is the vertices. So 1 0 0 5. Boom. So they are automatically smaller. So it's closer to the original thing that we had. I think that's much better. Let's give it a try. Okay. Yeah. Okay. Something weird going on, right? Is there a little bit of offset? It kind of looks cool as well, by the way. Just saying. Interstellar. Yeah, Interstellar. The offset is still 1. The offset is still 1. The offset is still 1. Not really sure what that's supposed to mean in the code. Cool. All right, so let me see. Let me see. Oh, v33, v33, 1. Okay. Yeah, that's a good one. Thank you so much. What is... it's kind of bizarre. Why it didn't work though? Why it didn't work though? Cubes have the size and FPS goes for X. What is it? Is it due to floating point numbers? I think, like, I'm not really sure why it is like that. It probably has something to do with how we chunk the triangles, right? So I had a chunking renderer, which takes the bigger triangles and tries to split them into the chunks, but I haven't really finished it properly. So yeah, ideally the size of the triangle should not really affect how it performs, but it does. We're gonna fix that a little bit later. Okay, so this is the offset is that. Let me take a look at the place cube. So this is a place cube. So this is that. What we're doing here is just like we add, then rotate, size and position. For the people who talk about the matrices in the chat, I know about the matrices. I will introduce them later. Right. Don't worry about it. We're gonna have an entire separate stream where we introduce matrices, quaternions, and stuff like that. Don't worry about it. I'm aware of all of that stuff. Okay, you're just running ahead too much. Yeah, so that's kind of interesting. Let me see. let me see. So this is the thing. So this is the rotation. What's the, maybe there is a difference between this thing and whatever I have in the place cube. The real question is just like, I'm not sure why it appears to be different. Why it appears to be different, because it's also the center of the mass is sort of like at 0, 0, right? And the sizes here is half. So I suppose the math should just work the same way, but it doesn't. So there's something different between them. Let's try to run it one more time. Let's just run it one more time. And yeah, so this is kind of different. Yeah. So n, it's just smaller. That's the thing. It's just smaller. And then if I go place Blender cube, let's replace it with just cube. Let's replace it with just cube. And it's fine. What's the difference? Vn is still multiple by 1, but we don't use Vn. Didn't OBJs had scaling options? Do they? Thank you, Spritten. You're freaking saber. You lightsaber. So OBJ-C, yes. Scale. All right. How do you remember all of that shit, bro? What the fuck? Freaking okay. And it's exactly 70. It's exactly fucking 75%. Ah, the hacks I've put in the past are haunting me back. They're haunting me back. God fucking damn it. Ah, the hacks. Never put the hacks, chat. Never put the hacks. Okay, so Babaji to C. Babaji to C. So what we want to do in here, by the way, is just like, but I'm glad that I turned it into a flag and I didn't hardcode it. Well, I hardcoded the default value, right? So, but then now I left myself like an option to actually set it back to 1. So that's actually kind of nice. So maybe it's not that bad. It's not that bad. Look at that, chat. And then okay, so look at the FPS, and then I disable Back-Face Culling. Ah, I forgot. Hold your chargings. Hold your chargings. Shut up. Shut up. So where is the, yeah, so it has to be blender cube. All right. So we'll just try to do that. Holding it. Okay. Look at the FPS. Enabling Back-Face Culling. Pretty much nothing changed. But look at that speed up. Now that's what I call an absolute budgeting. That's actually kind of fucking epic. Holy shit. And yeah, so if we go into, yeah, so now we can clearly see. So the near clipping plane stuff is actually, yeah, near clipping plane stuff is actually kind of fucked up. Honestly, it's kind of difficult to tell whether the Back-Face Culling is enabled or not. Maybe we have to do something like this. So let's actually put something like a Back-Face Culling. And it's going to be S. So, and we can do Back-Face Culling. True, otherwise false. So we can do something like that. Right. So right now, as you can see in here, just like you can clearly see that it's false, and then I enable it, it becomes true. So we can clearly see it now. So is there any common abbreviation for Back-Face Culling? So can I just call it BFC? Like what's the abbreviated term for Back-Face Culling in the industry? I'm not a 3D programmer. So yeah, because I don't really like how it is, how huge it is. It's called BC. Okay. So OpenGL enable Back-Face Culling. GNU BC. Callback. Maybe. Call face. So call face. Maybe you can call it cull face. Cull face. Yeah, that's fine. Call mode maybe, yeah. True, false. On top of that, I can also do something like, it doesn't really have to be in parentheses, fog, right? I also have a parameter to disable fog. Fog, true, false. Without the fog, it looks like shit, honestly. Right. So this is how it looks like. Like the fog gives it at least a little bit of a depth until we implement it like a simple lighting. So how is it called? Like I want to implement like a lighting which uses normals of the triangles and how, you know, how they diverge from the global illumination. So it's sort of like a Phong, or it's probably not Phong, but I don't remember. Yeah, Phong. So I want to implement like a Phong style lighting, and it's probably only going to be global illumination. I'm not sure if we're going to introduce any like sources of lights, or maybe we could, like with some sort of like a bake lighting. Phong, yeah, it's a Phong. Oh, it's, yeah, it's so, feels so much nicer. Feels so much nicer. Okay, that's cool. It's very cool. And honestly, maybe it makes sense to just always now enable cull face. It probably makes sense to just always keep it enabled, right? Because it's, we fix the meshes, and having it always enabled means that I was always gonna have a check whether I have a proper winding order or not. And I'm not sure what the fuck is, like, why is it orbiting like weirdly like that? So but anyway, I'll fix that a little bit later at some point. I'll fix that a little bit later. By the way, I remember a very cool thing about Utah-Tipot. Utah-Tipota. Where is the Utah-Tipota place? Utah-Tipota. Let's remove the Blender cube. Let's put this thing in here. The floor. We need to fix the floor. That's true. We need to fix the floor. Okay, so look at this. If I look from the above, look at the lid, right? It looks fine, more or less. I can't look down, by the way. Don't worry about it. I enable Back-Face Culling, all right, and you can see there is sort of like a gap in here, because this, through the gap in the lid, you can see back faces of the Utah-Tipot, and it's kind of funny, right? But then I can disable, and it's fine now. So it's kind of funny. It's kind of funny. Yeah, it's pretty cool. Something weird going on in here. Is it clipping through the wall? Is the motherfucker clipping through the wall? Ah, the motherfucker's clipping through the wall because I set its scale to 1. Yes. All right. So for the Utah-Tipota, we probably don't need to scale it. Okay. So that's, yeah, 0.75. Now it is not clipping. Okay. So that's pretty cool. That is a pretty poggers. I'm already streaming for almost 2 hours. If I go into the fixing near clipping plane, it's probably gonna take like 3 hours or something like that. So I wanted to keep today's stream short. So I feel like I'm gonna actually finish it in here. So I think I already done a pretty good job on what I wanted to do today. So yeah, I'm gonna fix the rest of the stuff already off screen. I don't think I will encounter anything interesting in there. I'll just have to go through my hard-coded mess of different corner cases and just, like, you know, fix the winding order. So that's the thing I'll have to do. So yeah, it's kind of cool. It's kind of cool. It's all coming together. The game is coming together. Too bad it's kind of difficult to work on this game because, as I already said, I wanted to work on this game sort of in the background while doing other content. But doing other content is basically like a job. So working on this game feels like working on your pet project separate from work when you have a spare time, which you don't really have that much of because you're cranking up these slopics. So it's kind of sad. So this is one of the reasons why the YouTubers who's making a game never really finish their games, right? So because they have no time to make the game because they're making fucking content. Right, so, but yeah, So I just like don't really have super high expectations on when I'm gonna finish this game. It's a slow cooking game, right? So I specifically set up myself that it's not gonna be super fast. It's just like cooking in the background, occasionally working on it, occasionally making some streams like right now, and yeah, it's going somewhere. It's going somewhere. So we are slowly employing different optimization techniques. We're exploring different optimization techniques, and so it becomes faster. And as it becomes faster, that means I can cram more content into the engine, and maybe make something interesting. All right, that's it for today. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all on the next recreation program session with Mr. Azuzin. I love you all. Mwah.